Hi, in this video we're going to take the first look in vectors in terms of what you need to know for GCSEs. So a vector is basically any way to define a movement. So here's a typical vector, and the top number tells you how far to go left or right, and if it's minus it's to the right, and the bottom number tells you how far to go up or down, and again if it's minus you go down. So this vector means go 4 squares left and then go 1 square down. So there's a couple of vectors. Typically vectors are represented by bold letters, to tell them apart from simple like terms or expressions. So again, the top number tells you how far you go left or right. If it's positive you go right, if it's negative you go left, and your bottom number tells you how far you go up or down. Positive for up, negative for down. So this vector tells you go 2 to the right, and then go 1 down. Okay. When you're defining vectors, really important, you must say right or left rather than across. A lot of people say across, and that kind of ambiguous, do you mean right or left? This vector here, same idea, this is negative, so it'll be 3 squares left. This number's positive, so it's going to be 4 squares up. So that's how to read vectors. Okay, so I've mentioned vectors don't care about starting points. All these 4 vectors are the same vector, 3, 2. So you'll represent to go 3 squares across and then go 2 squares down. We can also have multiple quantities of a vector. If I have 3 lots of the vector 1, 2, that means go 1 square across and 2 squares down 3 times. And this overall effect will be to go 3 squares across and 6 squares down. So if you have 3 lots of a vector, you just times each of those numbers by 3, pretty much the same way you would if you expand in brackets. So that's going to be 3 minus 6. Again, we can also combine vectors. We can add vectors together. So here, I've got the vector 3, 5. That goes from here to here. Then I'm going to add on. After that, I'm going to go to the vector 1, 4, which I've done in red. And the overall effect is to go from this point to this point. So we can look at this. Look at this vector. I have gone 4 squares along, and I've gone 1 square up. So this vector is 4, 1. And that's the effect I got from applying both these vectors. First going 3 right and then 5 up, which is over here, and then going 1 across and 4 down, which is over here. So these 2 vectors added together gave me the effect of 4, 1. And the way we work it out without a diagram, all you need to do is add the top numbers together and add the bottom numbers together separately. Okay, let's have a look at some basic questions. So here we've got 3 vectors we're going to use, just see the typical kind of questions you see that use vectors. So write a single vector, 3 lots of A. For that we just triple this vector, I'll triple both of the numbers, so that will be 12, 3. 2 lots of C, we double C, give us minus 2, minus 6. A plus B, add these together. Again you add your top numbers together, so 4 plus minus 2 is 2, and then your bottom numbers together, 1 plus 0 is just 1. D, we have 2 lots of A plus 3 lots of C. So if I double A, I'm going to get 8, 2. That's 2A there. And we've got 3 lots of C, so we triple C. That's going to be minus 3, minus 9. So that is 3C. Note, when I write vectors, because I can't write in bold, obviously, we just typically it's mathematical culture, just to underline them. Then we add them together, top plus top, bottom plus bottom. 8 plus minus 3 is 5, and 2 plus minus 9 is minus 7. And it'll be the same idea for E, but I won't go through it. Okay, again, you can also have to draw vectors. Typically in exams, you'll be given some sort of start point. So it might say, draw the vector 2A, starting from this point here. So let's go through that. 2A we worked out earlier, actually. We know that's just 8, 2. So that means go 8 squares across, so 2, 4, 6, 8, and then go 2 squares up. So the vector 2A is going to be that. The vector minus A, so we know A is 4, 1. If you want minus A, all you need to do is just flip those signs around. So pluses go to minuses, and minuses goes to plus. Again, we'll draw that from here, we'll say. If we want minus A, we need to go 4 squares backwards, so 2, 4, and then 1 square down. So it's worth noticing, if I drew A, let's draw it underneath. That's the same vector as minus A, however it points in the opposite direction. So when you draw these vectors, it's really important to draw those arrows to show it's where it's pointing. Okay. Again, a plus c, you do the exact same way. You would add the vectors a plus c together, which gives you 3 minus 2. And then that means go 3 squares across, and then 2 squares down. So that there would be the vector a plus c. Okay. So your basic exam questions and vectors tend to look pretty much like that. Again, I won't go through these because I've basically gone through them already in the same fashion. So let's move on and let's see what other skills we can do with vectors. Next, we can solve equations of vectors. So this is saying some vector plus the vector 3, 2 gives me 7, 11. When you solve these equations, you basically have two equations in one. So you basically cut this equation in half, and we're going to solve the top half and the bottom half together. So from the top half, we know that x plus 3 is 7, so therefore x must have been 4. And then we solve the bottom half the same way. Y plus 2 is 11, so y must have been 9. So in vectors, you can always chop them up for different rows if you need to sort of solve more equations. Okay, we can also find the magnitude or length of vectors. So what that means, here we've got the vector 3, 4. Let's do a quick sketch of that. So the vector 3, 4 means go 3 squares along, then 4 squares up, and that is my vector 3, 4. When it says work out either the magnitude or the length, what it's actually asking you is how long is this line? And we can do that, and that is just simply done by using Pythagoras. You kind of see what I've already drawn here is a simple right-angled triangle. So if this has length, we'll call it x. We know from Pythagoras' theorem, which is a squared plus b squared equals c squared, we must have 3 squared plus 4 squared equals x squared. Then we just solve that. 3 squared plus 4 squared is 9 plus 16, which is 25. So 25 is x squared, so x is 5. That means the length of this line, it was 5 units long. Again, we don't have centimetres. If we did, we say 5 centimetres. If not, we just say it's 5 units long. Let's see that idea again. Here we've got a vector minus 12, 5. So we'll start here. That means go 12 squares back, or 12 squares to the left, and then 5 squares up. And again, just as before, this is going to form a right angle triangle with two lengths 12 and 5. We're going to find the hypotenuse. So we do 12 squared plus 5 squared equals x squared. Then solve that equation to tell us x is 13, which meant this length was 13 units long. Last idea. So here we go 2 backwards and 2 up. Again, we've got a right angle triangle. To find the length, you would do 2 squared plus 2 squared equals x squared. 2 squared plus 2 squared is 8. So 8 is x squared. And then to undo the square, we need to square root. So that means x will just be the square root of 8, which to three different figures, you would say is 2.83. So for most of these questions, the length tends not to be a whole number. Last thing to do with vectors that we're doing in this video is basically intertwine them with coordinate points. So here we've got the vector PQ, and we're told that is 4, 2. So this notation PQ, that means if I start at P, and then I go 4 squares along and 2 squares down, that will take me to vector Q. Okay? So that's the vector 4, 2, or 4 minus 2. Question then says, find Q if P is 113. Sorry, that shouldn't say 113. These should be coordinate points, these shouldn't be vectors. Okay, so we know that P is 113. And from this vector, we know I've gone 4 squares along and I've gone 2 squares down. So if I go 4 squares along, that means I've gone from 1 across to 5. If I've gone 2 squares down, my height used to be 13. Now my height is going to be 11. Okay, and that's all there really is to it. Let's try one more, the same idea, but here we're going backwards. So we're given what Q is, so minus 721. And we want to go backwards to work out what P is. So it's the same vector. However, here we are told that Q is minus 721, and we want to work out what Q is. So we just need to work backwards. So we can see to get from Q back to P, I have to go 2 squares up. So that means my y coordinate is going to be 23. And I have to go another 4 squares to the left. So my coordinate was minus 7. If I go another 4 squares to the left, that will now be minus 11. Okay, and that's it. So working backwards is a bit more awkward, but it's the same basic idea. Okay, so we'll go through this idea. Again, there's a lot of multivectors that I'll cover in future videos. Hope for the time being this introduction made sense to you.